Alright, in our exploration of real numbers so far we've looked at some definitions, we saw a few properties, we've looked at adding and then subtracting real numbers, and it should come as no shock that now we're going to move on to multiplying real numbers. Let's start out with a few properties of multiplication. And this will be a little bit similar to addition where we saw some rules that applied. So we'll start with the commutative property, which tells us that we can change the order in which we multiply two numbers and still get the same product. So we can take a times b, or we can switch that order around and take b times a instead. We'll get the same answer. So for example, if we take 8 times 5, that will of course give us 40. We can switch the order, reverse the order, make it 5 times 8. We still get 40. So for multiplication, the commutative property applies. The associative property, remember, has to do with grouping. If we are multiplying three numbers, we can group them in any manner that we want, and we're still going to get the same answer. So in the first case, we can take a times b grouped together, then multiplied by c. That will give us the same result as if we had grouped together b times c, so that multiplication would take place first, and then multiply a times that. So as an example, we can look at 2 times 3 within parentheses would give us 6, and then we're going to multiply that times 7, which will equal 42. Or if we had instead grouped the 3 times 7, that would tell us to take 3 times 7 first, which would give us 21, and then 2 times 21 still gives us an answer of 42. Okay, so again, it doesn't matter what sort of grouping we use for those as far as which pair will get multiplied first. Again, this only works for addition and now multiplication. The identity property. Remember, the identity property is when you apply some operation and you get the same answer back that you started with. So if we take the product of a number and 1, we'll find it's the number that we started with. And this means that 1 is the multiplicative identity. So if we multiply 1 times any number, we get that number right back again. So a times 1 is simply a. And by the way, that's one reason why we don't always write 1a or 1x or 1y. We already know it's a or x or y. So if we take negative 4 times 1, we get whatever we started with, which in this case was negative 4. The property of 0, this is for multiplication again. The product of a number, any number, and 0 is 0. So if we take a times 0, that's the same thing as, remember, the commutative property. We can switch the order and make it 0 times a. Either way, it's 0. So if we take, for example, 9 times 0, well, we get 0. Here we have a couple of rules of multiplication. Really, when we're talking about real numbers, again, we're focusing on positives and negatives. We really only have two rules to remember here. So first of all, multiplying numbers of the same sign will give us a positive product. Please keep straight, this is for multiplying. This does not apply to adding or subtracting. Okay, so for multiplying numbers of the same sign, product is positive. So if we take a positive times a positive, 4 times 7, we get a positive, 28. Likewise, if we take a negative times a negative, same sign, so a negative 3 times a negative 7 will give us a positive, 21. If we multiply two numbers that have opposite signs, then the product will always be negative. So if we take a negative times a positive, negative 4 times 7 will give us negative 28. Or if we take a positive times a negative, so again, opposite signs, negative positive, positive negative, 9 times negative 3 will give us negative 27. Let's look at a few examples. Okay, find the product negative 3 times negative 4. Well, one thing you can do here is figure out right away what is the sign going to be. Well, if we're taking a negative times a negative, that's a positive. So we already know it's positive, and now focus on what is 3 times 4, which is, of course, 12. So that's our answer. Number 2, again, find the product, negative 3 times 6x. Now, if you want, remember you can think of 6x as 6 times x, so we're really multiplying three quantities. Negative 3 times 6 times x, but we don't know what the x is, so it's going to remain there. But we can focus on what is negative 3 times 6. Well, negative times a positive is a negative, and then 3 times 6 is 18, and then we're still going to need to multiply that times x. So we can simplify that to negative 18x. We still, of course, don't know the value of this term until we know the value of x. Number 3, find the product. And so here we're going to multiply several numbers together. Now before you get all antsy and you think, oh boy, I have to multiply, I have to worry about negatives and positives, and I've got decimals here. Well, before you fret or worry or go grab a calculator, notice this value right here. Okay? When we're multiplying a series of numbers together and there's a 0 that shows up, automatically our answer is 0. It doesn't matter what all these other numbers multiplied together will give us. All of that put together, multiplied together, times 0 is still 0. And number 4, find the product. Negative 2 times negative 3 times negative 4. Now remember, with the commutative property, it really doesn't matter what order we multiply these in, but I'm going to go ahead and work left to right. So I'm going to take, first of all, negative 2 times negative 3. Well, a negative times a negative is a positive, and then 2 times 3 is 6. We still need to multiply that times negative 4. Now we have a positive times a negative, which means negative, and then 6 times 4 is 24, and there's our answer, negative 24. Now you might notice a shortcut. Maybe you already know this. If you're not already aware of it, maybe you'll find this. I don't want to just spell it out for you. I'd like you to find it. There's a shortcut for knowing. Let's say we were multiplying 10 numbers together. We could figure out very quickly whether that final product is going to be positive or negative. And here you can think negative times negative, positive times negative is negative. But if you don't already know that shortcut, that quick way to figure out whether it's going to be positive or negative, look for that in some of the examples that you work on and see if you can spot the pattern.